What made Panzer IV a Blitzkrieg game-changer? Designed in 1937 as an infantry support platform, the Panzerkampfwagen IV, Panzer IV, underwent significant evolution from the Ausf-D to the Ausf-J, reflecting a series of calculated enhancements aimed at countering the formidable T-34 and M4 Sherman. Initially, the Ausf-D featured 20mm side armor and a 75mm KWK-37L/24 gun, effective against infantry but inadequate against the T-34's sloped armor. Subsequent models saw frontal armor increase to 80mm, and the adoption of the longer 75mm KWK-40L/48 gun, enhancing anti-tank capabilities. In contrast, the T-34 maintained superior mobility with its wide tracks and Christie suspension, and its 76.2mm F-34 gun remained effective throughout much of the war. The M4 Sherman balanced firepower and mobility, but faced challenges against upgraded Panzer IVs. Ultimately, while the Panzer IV's incremental improvements enhanced its combat performance, they could not fully mitigate the advantages held by the T-34 and Sherman in terms of mobility and production efficiency. The Panzer IV's chassis featured a compact, welded hull designed to optimize mass distribution. Early models used 10 to 30mm armor, later augmented to 50mm in frontal sections for enhanced survivability. Field crews sometimes retrofitted additional steel plates to vulnerable lower sections, countering the impact of Allied 75mm rounds. The turret, engineered with a low-profile design, utilized an 80mm frontal armor plate in advanced variants and minimized target silhouette while integrating a hydraulically assisted traverse mechanism for rapid engagement. Manufactured with precision, the Panzer IV's armor plates were rolled homogeneous steel, then welded into a monocoque structure. This approach reduced production time and ensured uniformity across units, although early weld seams were occasionally vulnerable to concentrated high-velocity impacts. Refinements in welding methods eventually improved structural continuity and resistance. Later variants incorporated turret and hull-mounted smoke dischargers to obscure targeting, while refined camouflage schemes minimized visual detection. Upgraded self-sealing fuel tanks reduced fuel spillage by roughly 40%, significantly diminishing post-hit fire hazards. Internally, a five-man crew was allocated within a compact, functionally segmented space. The driver, gunner, loader, commander, and radio operator benefited from an optimized layout that minimized movement delays and improved communication under combat stress, directly contributing to the tank's operational efficiency on the battlefield. The internal layout segregated the fighting compartment from ammunition storage, with blast-resistant bulkheads shielding critical areas. This design, coupled with improved ventilation and overpressure relief systems, effectively mitigated the risk of internal explosions under enemy fire, ensuring enhanced crew survivability in prolonged engagements. Can refined design and raw power tip the scales of war? The Maybach HL120 is a 12-cylinder, 21.4-liter gasoline engine, delivering roughly 300 horsepower at around 3,000 revolutions per minute. Its robust design ensured steady torque output, achieving a power-to-weight ratio of approximately 12 horsepower per ton for a 25-ton chassis, critical for maintaining momentum during sustained operations. Coupled with a 6-speed transmission and single reverse gear, the engine's output was efficiently managed across varied terrains. The tank's torsion bar suspension, paired with overlapping road wheels, absorbed shocks while preserving track alignment. Reinforced, articulated steel tracks provided exceptional grip on mud and uneven ground, minimizing slippage and wear under combat stress. Capable of reaching up to 40 kilometers per hour on roads and maintaining steady cross-country movement, the Panzer IV's mobility was optimized for rapid repositioning. Although Allied vehicles like the M4 Sherman featured higher power outputs, the Panzer IV's balanced drivetrain and durable suspension offered reliable, enduring performance in diverse operational theaters. Wehrmacht maintenance records indicate an operational availability exceeding 70%, while crew accounts highlight its mechanical endurance and straightforward field repairs. The early 75mm KWK-37 featured a short-barrel L-24 delivering a muzzle velocity near 600 meters per second, firing both high-explosive and armor-piercing rounds. Its design suited early war engagements, but as Allied armor thickened, the upgrade to the 75mm KWK-40L/48 became imperative. The extended barrel increased muzzle velocity to roughly 800 meters per second, with APCBC rounds capable of penetrating up to 120 millimeters of armor at 1,000 meters, marking a decisive leap in anti-tank performance. The tank's coaxial MG-34, 7.92 millimeters, provided continuous anti-infantry cover at roughly 800 rounds per minute, while select variants featured a turret-mounted MG-42, delivering rapid suppression during close combat engagements. A fixed optical sight with a simple reticle enabled quick target acquisition, optimized for 300 to 500 meter engagements. Manual traverse and elevation adjustments allowed operators to maintain a steady rate of fire, typically 8 to 10 rounds per minute, even under battlefield stress. The Fuji-5 radio system enabled voice communication up to 2 to 3 kilometers, allowing coordinated breakthroughs and encirclements. Engineered for excellence, but would its might survive war's ultimate trial? The Panzer IV's engagement in the Battle of Kursk in 1943 highlighted both its strengths and limitations. While the tank's firepower was effective, the battlefield's terrain and the presence of advanced Soviet armor necessitated continuous tactical adaptations. Throughout 1943, German forces lost approximately 2,352 Panzer IVs on the Eastern Front, underscoring the intense combat conditions and the tank's pivotal role. In the lead-up to D-Day, Panzer IVs constituted about half of Germany's tank strength on the Western Front. The bocage terrain of Normandy favored defensive operations, allowing German tanks and anti-tank guns to inflict significant casualties on Allied armor. However, the dense hedgerows also hindered tank maneuverability, leading to challenges in offensive operations. The side skirts of the Panzer IV, designed to counter shape-charge anti-tank weapons like the British PIAT, were often torn off during movement through dense terrain, reducing their effectiveness. Following the Allied invasion, the Panzer IV continued to serve as a backbone for German armored divisions. However, the increasing prevalence of Allied tanks equipped with more powerful guns, such as the American M4 Sherman with the 76mm gun and the British Firefly with the 17-pounder, posed significant threats. Despite these challenges, the Panzer IV's 80mm frontal hull armor provided resilience against many Allied anti-tank weapons, though the turret remained a vulnerable spot. The Panzer IV's evolution throughout World War II reflects a balance between innovation and adaptation. Its initial design shortcomings were addressed through continuous modifications, allowing it to remain a formidable presence on the battlefield. However, as Allied forces adapted and introduced more advanced weaponry, the Panzer IV's limitations became more pronounced. Understanding the tank's operational history provides valuable insights into the dynamics of armored warfare and the complexities of military innovation under combat conditions.